Okay, I'd like you to try problems B and C. Because again, I'm assuming part C, do parentheses for first. I'm hoping you can do this. So with the fractions in there, let's just try it. When you're done, compare with the person sitting next to you. See if you got the same thing. After we do these two problems, we'll move on. We have to at least get through the fraction section today. My goal is to get through the whole packet before Labor Day so that we can test before Labor Day and you can just enjoy your weekend. Does that sound like a good plan? Rather than testing the day to that? Because I'm brilliant. Go. When we finish these two problems, I'll just have you like tell me what you got and guarantee there's going to be different people get different things. We'll go over them and see who got the right answers. I've learned that the board shakes when people walk upstairs. That's the perks that I didn't experience in the trailer. Just downstairs. I guess that's something that I should confirm, right? Everybody's been through secondary too. All right, part D, what did y'all get? -3, anything else? Really? Brilliant. Hey, let's try it. So, you can look at a fraction as still kind of a grouping symbol. So it says to use parentheses, but that fraction line does group the top versus the bottom. So this would be 2 times -1 minus 1, right, if we took care of the exponent. -2 minus 1, which would be -3, and you get -3. Feel good about that. Okay, part D, have you had time to finish it? -2. What else? Who got something other than -2? That's it, you all passed. Okay, I don't know what it is. Anybody get something different? -2 as well? Okay, let's try it. So looking at this parentheses, this will be 1 squared. This one, we can change that to a plus. So that becomes 6/3, right? Is that okay? So far, so good? So this becomes a 1 minus 6 minus a -3. -5 plus 3, -2. Good job. Okay, moving on. I didn't do that yesterday, and then another teacher said that her students struggled with fraction 1, so I'm currently not a better class. Okay, solving equations. We're only going to do a couple of these as well. Hopefully you've been solving equations for a long time. You kind of have a gist of what to do. Quantification you need a refresher, the very first thing I would do when I was solving equations is get rid of the parentheses. To get rid of, we'll do part A, this parenthesis, what would you do? We're going to distribute. Fantastic. So you would get a negative 12x plus 8 minus 8x equals 168. After the parentheses go away, we will combine any like terms that we have. In this case, we got that minus 12x and the minus 8x. Together make a negative 20x. So those combine. And then we'll get rid of the 8, right? So negative 20x equals 160. And then we would do what? Did I screw up? We're good, right? So divide by a negative 20. Final answer, x equals negative 8. Sorry if I didn't leave you enough room there. X equals negative 8. Feel pretty good about it. Any questions for the equation? Why don't you do part B on your own? Let's just make sure we each get the same thing. Part B. And then compare yours with mine. Mm-hmm. There were like 5 or 6 things that felt like we really needed to know. Moving in. This unit, or this section is called Numeracy, which is how you work with numbers. So we'll go through fraction rules. We're going to go through exponent rules. About half of our test this year, there's going to be a calculator section and a no calculator section. So you need to know what 5 to the 0 is, or what 2/3 to the negative 1 is. We'll go through that in a second, but that's fun. Oh, it's still going. At some point, did you get like a something equals 0? Final answer B equals 0? Great. You got that. All right, one last one before we move on. How would you do part B? B. Yeah, the cross. What's that called? Cross multiply. So when I multiply that 5 through, we're going to multiply it to the 3x. And then we'll multiply that way. Subtract the 15x, and x equals what? Cool. Try part S, and then we'll move on. Any questions so far? Am I going too fast, or do you guys okay? Let's try one more fractional one. Change that to a 3/1, the cross multiply would work. So So you would get a 6, 6 plus 1. You could distribute that 6 at the same time, or you could just leave it like that. You multiply that way. Then what? Is that an okay first step? Distribute there. So Scarlett's kind of ugly. You want to get a 4x over. It will become a 2x. You want to get a 6 over. 2x equals 6, so x equals 6. Here's this. Y'all are being really quiet now. Boring? This first line right here. So I changed this to a 3 over 1. And when my calibration stuff off. You got it? You did that? Yeah. I'm still getting this stuff. Yeah. Okay, so I think what we're going to do is, we get out in 20 minutes. I'm going to hand you your homework. We won't get all through day 1 today. So your sections are going to be like off a little bit. Next time we'll finish 1 and we'll get across as few as we can, and then eventually we'll get caught up to where I want it to be. We're still going to be doing the notes, so don't put too far away. I just want you to try 1 through 12, which are the equation order of operation ones. And all right, there's some time in the near future that we're going to be talking about fractions, and not just fractions with numbers, fractions with expressions. So on top it might say x squared plus 2x plus 1. And on the bottom it will say x minus 1 or something. So before we get into the fractions, like the crazy fractions, let's just review some of the fraction rules. And again, I know that you did this a long time ago. Hold on. There we go. I know that you did this a long time ago, but just as a review, let's do it again. Okay, how do you add fractions? What is necessary when you add fractions? You have to have a common denominator. So if I'm looking at part A, and I know that now y'all are sitting with your buddies, so just be with me here for a minute longer. If you're adding these two, common denominator would be 10, right? If I want to make the 2/5 a 10, the bottom goes from a 5 to a 10, the 2 has to go to a what? 4, you double it. Once they have a common denominator, you just add them. Final answer for this one would be 7/10. Cool. So there's 2 of each kind of these. I guess there's 3 of this one. Subtractions is just the same way as addition. What would the common denominator be on part B? Oh, you could do that. If you cross multiplied, would that be a common denominator? Yeah. It would be really big. But it would, oh, maybe not. It's blank now. Yeah. It doesn't matter. You could say 120. 120 probably will work. Not the smallest one, though. Anybody know the smallest common denominator? 36? If I want this to become a 36, what did I do? I times it by 2, right? So the top would be 2. What, 1 times 2? If I wanted this guy to be a 36, I needed to multiply it by what? 3. Multiply the top by 3. You get a 15. There's a subtract in the middle still. Subtract those out. If you can reduce them, you need to, but you can't reduce them. All right, let's just confirm that you can add fractions. Try part C on your own. The other reason that this is helpful is because you will have times where you don't have a calculator. Just so you know, the next class you take after this is pre-calculus, which is college algebra, 1050. You have to take a math class. It doesn't have to be this. It could be personal finance or accounting. But you have to pass college algebra to graduate from college, and it's going to be much easier in high school and much cheaper in high school. So I would plan on taking that your senior year. College algebra, 1050. It's the next one. Common denominator is what? 50. This first guy, to go from a 25 to a 50, you have to double it. So the numerator would be a 24. The second one, to go from a 10 to a 50, you multiply by 5. So you get a 65. Add those together, final answer. Fantastic. No, that's good. I'm happy leaving it like that. All right, part D. Let's go roll and multiply. You go straight across. Nothing has to happen. You could multiply and then reduce it, or you could reduce it before you multiply. Do you have a preference? I'm going to reduce and then multiply because it makes my multiply easier. The bigger the numbers, the harder they are. So if I look and notice that 3 and the 6, they have something in common, right? A 3. Divide the 3 out, you get a 1. Divide the 3 out, you get a 2, right? Looking at the 10 and the 15, now you didn't have to do it this way, right? You multiplied and then reduced it. The only problem with that is sometimes you miss things. You just have to be careful. They both have a 5, right? So the 10 has a 5 how many times? 2. The 15 has a 5 3 times. Now I'm dealing with 1s and 2s. Much easier. 3 times 1 is 3. On the bottom, 4. That is my final answer. And when we get to that point using our polynomials, we're going to do it the same way. We're going to have polynomials that are multiplied to each other. We're going to cross out the common ones. It's going to make it much faster. Okay, part E. Multiply straight across. The 5 and the 25, they have a 5 in common, right? The 5 becomes a 1. The 25 becomes 5. The 2 and the 24, the 2 becomes a 1. The 24 becomes 12. Multiply straight across. Because those are just 1 and 12 over 5 is the same one. There are a lot of different ways you can write that. 12 over 5 is fine. 2 and 2 fifths is fine. 4 is fine. I don't care. Okay, what's the divide rule then? We freeze the first one. We change this to a multiply, right? And then we flip this. So we freeze the first one, change it to a multiply, and then we flip it. And then we do the exact same thing as we did before. Hold on. So when I divide, the first number stays the same. The divide becomes a multiply, and you flip the last. That's it. And then you multiply it straight across like normal. I notice again that the 5 and the 10 have something in common. The 5 becomes a 1. The 10 becomes a 2. Final answer, 4/3. You okay with that? Yeah, up here. H. The simplify part. We're just going to look to see what something has on top and on bottom. Is that what you're asking? Okay, let's do part G and then ask it when we get there, okay? Okay, part G again is the divide. So we keep the first one the same. The divide changes to a multiply, and then we flip, right? That's not your question. Your question is the next part. when we start scratching them out. Well, I noticed that, I mean, this is really just one fraction, right? We could say it's 120 over 45, but those are big numbers, and big numbers, it's harder, it takes longer. But I noticed that there's a 12 and there's a 3, right? 3 goes into 12 4 times. So 3 divided by 3 is 1. 12 divided by 3 is 4. We divided both of those by 3. Same thing with the 15 and the 10. What goes into both 15 and 10? 5. 10 divided by 5 is 2. 15 divided by 5 is 3. Now I'm dealing with 1, 2, 3, 4. Much easier than 12, 16. Multiply those straight across, final answer, 8/3. Okay, one last one, which is good because time's pretty much over. This right here, is this add, subtract, multiply, or divide? Divide. It's the same kind of question as this. So this means 2/5 divide 14/15, right? When I divide, I'm going to make it into a multiply, and then what am I going to do? Flip it. So instead of 14/15, it's 15/14, and I'm going to assume at that point you know how to finish. Is that okay? Addition, no. Just multiplication, which is a good point. You can only start cross-canceling like this when we get to the multiplication. And on the division, you don't want to cross-cancel until it becomes a multiplication problem. We're out of time. So what I want is